Hi everyone, so I'm making a video on substitutions to solve systems of linear equation because I think some of us were having a little bit of trouble with the worksheet, and I just wanted to give you guys a couple more examples on how to do them. So I realized that you guys didn't have the guided notes, so it might have been a little bit difficult for you guys to follow, but hopefully you're able to do it just on a separate sheet of paper. So if you just want to continue on that separate sheet of paper for these three problems on substitution, please do so, and then you'll have an assignment following this as well. Okay, so substitution, all of these methods, substitution and later you'll do elimination, all of these are pretty much ways for you to find a solution, and the solution for all of these are going to be a coordinate. So all of them will have an answer that looks like x comma y. Okay, so you'll need two variables solved, x solved and y solved. Now you don't have to always solve for one specific variable. Sometimes it's easier to solve for x first, and then sometimes it's easier to solve for y first. So it just depends on the problem. Okay, so for example number 1 here, y equals 10, and then 8x minus 6y equals negative 20. These are our two equations, and we're going to try to solve for their solution, meaning like wherever these two lines cross, that's our solution, right? That's what we learned from the graphing. So for this problem, it's easiest to start with y because y is already solved. Y equals 10. So that's already going to be a part of my answer. That's going to be the y coordinate. Okay, so what I can do is I'm going to substitute. That's why we call it substitution. But we're going to substitute this into our second equation, and wherever we see a y value, because y equals 10, I'm going to substitute y with 10. Okay, so I'm going to do that right now. I'm going to do 8x minus 6 times 10 equals negative 20. Okay, so I substituted y into my second equation, and now I'm just going to solve for the missing variable, and the missing variable is x, which is the variable that we need to find our final answer. So 8x minus 60 equals negative 20. Solve for y, so I'm going to add 60 to both sides, giving me 8x equals 40, and x equals 5 when I divide both sides by 8. Right? So my final answer is not just 5, and it's not just 10, but it's a combination to make that coordinate. It is 5 comma 10. So if I were to graph these two lines, my intersection point would be at 5 comma 10. Okay, that's what that means. Let's try something a little bit different. So for example 2 here, we have 2x minus 3x equals negative 1, and x equals y minus 1. So this time, it looks like it's easier to substitute y, or replace x with this entire function into our first equation, because x is already solved for. So I know x equals y minus 1. So what I can do is I can substitute x with y minus 1, because I know x equals y minus 1 into the first equation. So you're going to see me do that right now. The first equation is going to be rewritten as 2y minus 3 y minus 1 equals negative 1. So all I did here was I swapped out the x with what I said x equals. X equals y minus 1. So x is replaced with y minus 1. Okay. And then now I simplify by distributing, combine like terms, and I solve for the y variable. Okay. So 2y minus 3y plus 3 I distributed this -3 to the y and the -1. So it turns into a -3y plus 3 equals -1. Right? Combine like terms gives me -y plus 3 equals -1. Subtract 3 to both sides. -y equals -4. And then y equals 4. Right, so I solved for my first variable. I still need the other value. I still need the x value. So I'm going to plug my y value that I found back into whichever equation I want. Now there's probably going to be an easier one to use. For this case, the second one looks like it's easier to plug the y back in so I can solve for x. So what I'm going to do is I'm going to plug in y back into this second equation. Okay. And I'm going to solve for x. So plugging that in, I get x equals 4 minus 1, which gives me 3. Okay. So those are my two answers that I need to incorporate together to get 3, 4 as my final answer. Right. So for these substitutions, it's really nice when we have like a variable isolated already. We can just plug in whatever that equals into the second equation. Sometimes it's not that easy though. Sometimes it's you need a little bit of extra help to solve for a certain variable, isolate a variable, and then you can start substituting. So for our last example, that's what we're going to do here. We're going to need to isolate one of our variables first in one of these equations, and then we can do our substitution. So for this problem, it's easier to isolate a variable in this second equation. And I'm going to choose to isolate the y value. I'm going to find y equals and then my equation, because I want to keep it a positive variable. It's easier to do with a positive variable. It's still doable to do with the negative one, but I'm going to say for our purposes, let's have our isolated variable positive. Let's try to make it positive. So what we can do to keep that y positive is add x to both sides, and we get y equals x plus 3. Right? So these are our two equations we're going to use. All right, y equals x plus 3. That's my equation with the isolated variable. So I'm going to substitute y into this first function with whatever y equals. Y equals x plus 3. So it's going to be replacing the y value in my original equation. Okay, so negative 3x plus 3 parentheses x plus 3 equals 4. Again, all I did was just replace y with x plus 3 because I know y equals x plus 3. And then now I combine like terms and I solve for x. Negative 3x plus 3x plus 9 equals 4. Okay, and you're going to see something interesting happens when I combine like terms. Negative 3x plus 3x gives me 0 plus 9 equals 4. So 9 equals 4. That doesn't make sense, right? 9 does not equal 4. So what happened here? So that means there is no way that I can have a solution here because 9 doesn't equal 4. Right? So this is actually no solution. And that's going to happen sometimes. When the two numbers at the very end, if you have no variables left over, are not equal to each other, like 9 and 4, then there's no solution. Okay. When there's no variables at the end, but the numbers are equal to each other, then there is a solution. It's actually infinite solutions. Okay? So keep that in mind when you try these problems. You're not doing it wrong if you cancel all your variables out, but you did the process right. But do make sure you checked all your variables, you substituted properly, and you did all your algebra steps properly. Okay, so this is substitution. You'll see another video on eliminations in a little bit as well.